everybody. My name's Andrew Kelly. This is my first talk that I've done in like 3 years, so I've completely forgotten how to do talks and stuff, so bear with me as I remember how to do this stuff. Thank you for staying back. Yeah, my talk this evening, I know the title says messing around with the Android manifest. I couldn't really come up with a good title. I just want to go through a couple of things that I kind of either learnt or discovered, recently or recently-ish, whilst doing some Android bits and pieces. So I thought it might make a nice blog post or a talk. So here are some slides, and I'll share it with you today. And hopefully you'll find it as useful or as interesting as I did. And there'll be some frank admissions as well, because one of these things I'm going to talk about this evening came out of a issue that we had in production. Quick show of hands, who here is Android developer? So I know who to throw my steely gaze at. Okay, cool, no worries, brilliant. All right, off we go. And last time I did a talk, I didn't have to wear glasses, so I'm going to just put glasses on to read my speaker notes where I've got all my jokes, and then take them off to actually say the jokes. That's how long it's been. Okay, so I work for a company called MX51. I build apps for credit card payment terminals. So this is essentially a fancy Android phone, if you want, with a printer on the back and a big battery and a credit card reader, and it has like a little dock where you can have Ethernet connections and stuff in the back. So I deal in Android versions that are really old, not Android 14. I'd love to be on Android 14. This one runs Android 8. There's some other devices on my desk at home that have got Android 10, some run Android 7. So the world of credit card terminals is quite far behind Android 14, so there'll be no gender-neutral string sharing on my talk. So our app is for merchants. So merchants use these software terminals. So our app is called the MXA. So if you see the MXA, I don't know if I've referenced it too much in my talk today, but that's essentially the name of our app internally at MX51. The app itself is white labeled for our customers, our tenants that we deal with, so the different banks that we talk to or the different merchant acquirers. There's different color schemes, different logos, all that kind of thing, so it's kind of white labeled. And one of the interesting things about credit card terminals, maybe it's not a surprise, there's no Google Play services on there, there's no Google Play Store, there's no Chrome browser, there's a whole lot of stuff that's not on these devices. So we develop software in a world that's quite different to a regular sort of mobile phone app. But still, if you know Android, there's a good foundation of stuff there. Anyway, so that's some context to some of the reasons why I'm going to be talking about some of the stuff we're doing tonight. So the first bit I want to cover off is Android manifest testing. So I imagine that a lot of you out there as developers will be doing unit testing for your Android apps or UI testing where you look at the screens. But you may not do, and maybe you do, maybe I'm completely out of touch with how Android developers work these days, but you may not do things around testing your configuration, so things like your Android manifest or your build scripts and things like that. So this is one of the bits that we did or added not so long ago to do some testing to fix some bugs that we had in our manifest files. So the first bit we're going to talk about is the allow backup configuration in the manifest. And here's a quick snippet of a manifest on the right. Our app goes through, as you can imagine, with various credit card things and banks and stuff, some pretty rigorous testing. So we do our own internal testing with our own QA teams, but then we have third-party external QA services, some of them provided by the banks that we talk to, some of them provided by external agencies that also test our app. So we have to send it off. People go through it, look at it, and go, hang on a sec, why are you doing this? They don't get to see the kind of the source code, but they get to try and decompile our app and take it to pieces to make sure it's all secure and all that kind of stuff. So one of the third-party audits that we had turned around and says, hang on a second, your Android app allows backups. That shouldn't be allowed on a credit card terminal. Why would you want to allow that kind of thing? So you go, okay, good point, thank you very much. So pretty easy, you can see we've got it missing there. If you don't specify the Android allow backup configuration in your manifest, the default is true. So the fix, as you can imagine, fairly straightforward. Stick in a line here, allow backup equals false. We stick in the tools replace tagline so that if there's any third-party library that also defines this value, we override that and say, no, we know best. This is what it should be. So fairly straightforward to fix, but we want to make sure that when we submit our app in the future for this third-party testing, this bug doesn't come back in, and we have to go through this, rigmarole again, because the certifications cost money. So we write a quick test. So here we have a sort of an Android test that's going to go in your Android module, not a unit test, because we're going to be testing an actual Android-specific component, which is the manifest. Quick run through the test itself. It's fairly straightforward. So we've got a compose test rule. Our app is built in Jetpack Compose. We're quite fortunate that it actually does run on these things. We grab the metadata for the app itself, which is that first block of code, and then we do a quick test to say, has the allow backup flag been set? Oh, yes, it has. Well, it shouldn't be allowed to be set. Boom, fail the test. So every time we do a build, we're going to check now that that part of our configuration is set correctly. So when we do these third-party tests, we always pass them. Straightforward. One of the other things that we did recently, well, not recently, we had a bug, and it was a regression, a software regression. And nobody likes software regressions. It means your app used to work, and now it doesn't work. So one of these happened to us. It happened in production, and I'll explain sort of how we got to that stage and then what we did to fix it. So as I mentioned, our app runs on credit card terminals, and whenever you take the terminal out of the dock, it causes an app configuration change, a bit like when you go from portrait to landscape, or if you change the language settings on your device, it'll trigger a app restart. So when you go in and out of the dock, it'll trigger one of those. As you can imagine, as a merchant, you might have this sitting on your countertop next to your point of sale. And then when a customer comes in and says, I want to pay for $3 coffee, you show them the machine, they tap the machine, you go, brilliant, thank you very much. You put it back on the dock, and it starts charging. So it's going to go through these configuration changes quite a bit. And we don't want that. So this isn't the actual bug, but this is one of the lead up to the bug. So because we don't want to restart every time we take the terminal out of the dock, we specify in our manifest that we're going to handle the UI mode changes. So every time the UI mode changes with the docking, the activity doesn't get restarted, because we don't really care that it's changed, come out of the dock. We're not going to change any part of the app. We just don't want to trigger a restart just at the point where the customer's about to tap their credit card. And obviously, people don't like losing their money or not knowing the state of their money. So if your app does weird things when people are about to tap a credit card on it, it's not a good look. So brilliant. We stick that into our code. Everything's great. At this point, we didn't have a test. So we stuck the line of code in the app, shipped it out into the wild, everybody's happy. One of the problems that we had is our app also lets you change between dark mode and light mode. Our app is Jetpack Compose. One of the easy things you can do there is with your theme, you can go, okay, you have a toggle on a settings screen somewhere, and you go, brilliant, I want to go from light mode to dark mode. It's a Boolean, essentially. You go pick out this set of colors rather than that set of colors. Everything works fine on your screens. It's all beautiful. However, that Boolean, which drives Jetpack Compose and the color scheme that it's going to use, doesn't affect system UI dialogues. So things like permission dialogues, other pop-ups from the system. So to do that, you need to use a bit of code that looks like this. Essentially, we're going to choose a mode. There's an app compact delegate thing that says I want to be in dark mode or light mode, or just let the system choose. So if the battery saver kicks in, it'll switch over to dark mode automatically. And then the last line at the bottom is the bit that sets the dark mode so that the operating system also is in dark mode to match the rest of your beautiful app. And this is where we had our bug. So that bit of app compact delegate code, when you change it to go from light mode to dark mode, triggers a UI mode change. Or it would do if we didn't have a line of code in our manifest that says, don't worry about it, we've got our UI mode stuff covered. So we'd broken our UI toggle for dark mode and light mode. So that came back as a bug from the QA team. We go, brilliant, we stick a developer on the case. They go, oh, hang on a sec, there's this weird UI mode thing in our manifest. Let's get rid of that. Light mode and dark mode fixes. Brilliant, bug is fixed. Ship it to production. Ship it to production. About 2 days, maybe it wasn't even 2 days, we start getting reports of the app restarting when people who are using Ethernet start trying to take money from customers. And you're going, oh dear, this is not good. And as you can imagine, this UI mode change that we've undone from the manifest file now means that doing this restarts your app just at the point as you're about to tap your credit card. Not great. So those phone calls came thick and fast. We worked out what the problem was. We came up with a fix. And then essentially what we did was had to write another test for our manifest to say, look, make sure that each of the activities that we care about, the ones that are managed by us, support that UI mode and don't let it get removed in the future for people who want to change code around changing to dark mode or whatever it might be. So again, here's our test. We grab our activity. We look at we get the list of activities this time from our manifest file, and then we go through them. I mean, this code is a bit wordy, but it's easy to read. We filter out the ones that belong to us because those are the ones we're going to manage. And we say, look, for each of those activities in the manifest file, make sure that the UI mode configuration has been defined. If there's one that's missing that, fail the test, and then we have some logging as well, so you can go into the test output and see which one is the one that's breaking the test. So those are the two kind of bits and pieces that happened to us recently, which then prompted us to start looking at not just testing around unit testing and UI testing, but to then include things like our manifest in there. Some other things you might want to do with your manifest testing if you want to take this idea and run with it and go crazy. Permissions, make sure you've got only the set of permissions that you want inside your app. So if you include a third-party library, that might need the camera permission. Well, I don't need the camera permission in my app. Why would I want that? So you want to sit there and say, well, look, make sure in the manifest it only has the permissions that we care about. Activities. You can export an activity. So if your app is made of 10 activities and only one of them is the one that people launch from the launcher, and the other 9 are just used internally in your app, make sure they're all exported equals false, so that other apps can't suddenly somehow launch those activities. Only your app can do that. And then the last one, deep linking. Deep linking is a tricky beast at best. There's lots of room for typos and errors and configuration bits and pieces in there that can go horribly wrong, and typos will really screw you over, and you won't find those out until it's too late. Again, a great candidate for having some tests in there. So some extra bits and pieces to think about if you want to venture into the world of manifest testing. The other bit I wanted to talk about this evening is something that we implemented this year, so fairly recently, our app initializers, or the Jetpack app startup library. And this is all to do around with performance and launching the app as quickly as possible. So for our app, it's not particularly important or critical. Our app only gets launched once a day, and it runs for 24 hours or 23 hours and 59 minutes, which is unusual for a lot of apps. Credit card terminals have this thing called a PCI reboot, so they have to be rebooted at least once a day. So it's guaranteed that it'll happen, at 2 in the morning or whatever. And then our app is the first app that gets launched, and it just sits there ready for the merchant to do all their bits and pieces. As a quote-unquote normal Android developer that you all are, this will be more important. So obviously, the speed at which you can launch your app is really important to the users. People don't want to be waiting, and this is going to really help. So this is a quick rundown of how you can kind of add this to your app. It's fairly straightforward, and the benefits that you'll have. So app initializers is defined in the Jetpack Compose, not just the Jetpack app startup library. As I mentioned, it can significantly improve the startup time of your app. It uses content providers to execute your startup code in parallel. If you've ever used Firebase crash reporting, this configures itself as a content provider as well. So this is how it gets started ahead of your main application class and any of your activities. So content providers get initialized before all the other bits and pieces. You can choose how your app initialization code is launched, and it's controlled by a dependency graph. So you can say this bit depends on that bit, so this bit over here needs to get initialized first. And if, like me, you used to have all of your startup code in your application class, it makes this class infinitely more tidy and easier, more readable. So win-win for everybody. I won't embarrass people by making them admit, does their application class look like this? Because it'll only make me feel bad when nobody puts their hands up and it was just me that had all this kind of stuff in here. So I've used the word a typical application class. This may not be typical, but this is how I've done it in the past. Essentially a big old onCreate method there, and inside that method I'm going to launch, set up my Timber logging framework. I use Coin as my dependency injection, so I'm going to set up my Coin dependencies. I've trimmed this down here to fit on the slide. There's only 6 there, but there's probably going to be 600 in an app if you've got view models, use cases, repositories, various abstractions over alarm managers and resource loading and all that kind of thing. We use the coil image loader as well, which needs setup if you want to support SVGs and GIFs and all that kind of stuff. So your apps have probably got a ton of other stuff in there like this, and at some point during the launching of your app, these all need to be configured. And in this one, can I go back? Backwards. Yeah, and one final note on this one is everything happens in order and is sort of sequential. So there's no parallelization here. Everything happens, one after the other. So it's pretty slow, or can be slow. Slow is a relative term. It probably takes, I don't know, 900 milliseconds, but slow can be slow. So here is a simple example of an initializer that sets up Timber. So the code that we had in the previous slide where I set it up, where I have my custom log line that says all my log lines in my app when I use Timber should start with the letter MXA, which is the name of our app. It makes it easier to find. Plant the debug tree, set the MXA tag, and away we go. So pretty straightforward. The initializer interface is defined on the top line, so there's only 2 methods you need to override. And the second one, the dependencies one, is where you can define what other things does this initializer depend on. So in the case of Timber, there are no dependencies on this. We can launch this whenever we like. Empty list. Easy peasy. Second one, as I mentioned, we use Coin as our dependency injection framework. So this is the initializer we have for Coin, obviously cut down again to fit on the slide. We can now start using our Timber logging. So I've stuck in a log line here so you can see that. And we've mentioned in our dependencies at the bottom that this one depends on the Timber initializer. Doesn't have to, obviously, but for the purpose of showing how these relationships work, it works on the slide. So now we know that this one will be invoked after the Timber one, so that when we have our log line on line number 3, it'll have the MXA prefix to that log line. So you can build up your list of initializers for all your different startup code, the third-party libraries that you use, your dependency injection, all the bits and pieces that need to be defined, and the order in which they need to be launched using this kind of simple pattern here. And to get this all to run, you just stick an entry in your Android manifest, back to the manifest thing from the title. The initialization provider is the bit that does all the magic. And then you specify the metadata tags underneath. I like to specify all of them, just because I don't want to miss any out and have something not get initialized. So the paranoid part of me says stick them all in there. But in theory, you only need to put in if you imagine like a dependency graph tree, you only need to put in the leaves at the bottom, because then all the dependencies that they find on the way back up to the root will be automatically initialized. So it'll go, okay, the Coin one depends on Timber, so I'm going to initialize Timber first, and then I'll do the Coin one. So you just have to have the extremities. So I just put all of them in there. Obviously, it's easier for you if you've got lots of them, then maybe it makes sense to have just a few in there, and it works it out auto-magically. So the next slide is I don't want to say that it's fake, but it's fake. Here is kind of a speed comparison between having some initializers that take about 3 seconds each running sequentially versus having them set up and running using the app initializers stuff. So it's kind of a comparison between the old application class way of doing things and the app initializer way of things. Prepare to be astounded by my animations. Here we go. So we're loading some stuff. Like I said, I've got some fake initializers happening. Each one takes a fake 3 seconds to initialize. Obviously, that's not the real case. For most applications, it's only going to be a couple of 100 milliseconds here and there for things like Coin and stuff like that and Timber. So yeah, the old way, you can see when we launched the content provider, so I've got a fake content provider to say that this is when the app is going to actually, is being kicked off. So we've got a date and time there of what it is, 1942. I did this afternoon. And then the application class is immediately launched after that one. And it does all the work. So this is the one where it's going to have a 12-second difference between the application classes on create and the activities on create. So that's doing, in this fake example, 12 seconds of hard work initializing the entire app. Now, if you look at this side here, which is the one that launched a whole lot quicker, you can see that the content provider is being launched. Now, because content providers is the engine that drives this whole app initialization stuff, the gap between the components is now going to be between the content provider and the application class. So at the moment, they're all running parallel. So there's only a 3-second difference between the content provider and the application class being initialized. And then you go from application to activity, and it's almost instantaneous because the application class is no longer doing that bit of work. So yes, it's a fake example. Yes, it's kind of comparing apples with apples, and these apples are 3-second startups. Your application is going to be different, but you can still see the benefits of, I'm not creating, magic here, the difference between serializing something and running something in parallel. And you can see this as a benefit to your app when you're launching it. One of the cool things you can do to get rid of that whole sort of blank white screen, which is I had, there's another Jetpack library for splash screens, and it will display the splash screen on application launch, and it will take the splash screen away when your activity renders its first frame. So the time to get to the first frame is really important. So the splash screen here will kind of show, for less time, obviously because it's doing less work, but it all kind of plays nicely with this whole app initializers framework. And that's kind of it. So fairly quick run through. Final thoughts is testing your config in your Android manifest is really easy. I advise you to do it. It may seem redundant, but it might save you one day. And configuration bugs can be some of the hardest ones to find. And if you do find one and it's in your manifest, it certainly qualifies as a stick as a test in there. And then on app initializers, the faster you can get people into your app, the happier they're going to be. And if you can get rid of the horribleness that was my application class with hundreds of lines of app startup stuff, even better. So happier developers as well. And that's it. So hopefully you'll find those useful. Any questions, shout them out. Otherwise, thank you very much. Everybody wants to go to the pub. Okay.
Hey, question. So when you're testing a manifest, you're testing the manifest or the application behind it. So for example, your example of a regression, should you test how it reacts to the reset or the manifest which might disable it or not?
Yes, good point. So we're testing that the configuration of the manifest is set up to work how we want it to work. So we're making sure that somebody hasn't accidentally deleted a line. We also have tests for things like if you toggle the dark mode in the app, the background color should go from white to black or whatever it might be. So we also have tests for that part of the app. So this is just another thing to make sure that the two different parts of our application, they're taking it out of a dock, which is really hard to simulate using a unit test, and the toggling of the light mode and the dark mode kind of work together, and we don't break one by changing the configuration of the other. So that one specifically makes sure that the manifest is set up correctly.
And speaking of the actual device, so once upon a time I was working in a company which were doing hardware, and no matter what software guys did, hardware guys will ruin. So if you're talking about some embedded things you cannot trust, you have to test the real device. So you have a test for real device?
Yeah, well, so we have, I was talking to Mitchell about this earlier, so we have our own, I want to say it's like a Firebase test lab. It's not, it's sort of 6 of these in a cupboard connected to a device running UI Automator tests, and we have a credit card sellotaped to the top of the credit card terminal. So we'll when there's a new build, it automatically downloads it, it sticks it on here, it runs through our UI automated tests, and then it kind of does end-to-end testing, so it'll run a real transaction against the back end of the payment gateway. It'll do a fake transaction using a fake credit card, and we'll get the results, and then we'll parse the HTML of the receipt to make sure the receipt is all in there. These ones are really flaky, obviously, because there's 1,000 things that can go wrong with a real test in a real environment. It's not very orchestrated. You know, networks go down, backends have delays, credit cards fall off the top of terminals because the sellotape gets hot because it's summertime. All these things can go horribly wrong. But yeah, we have a test lab for all the different hardware that we support. We want to get being sort of somewhat nerdy, I tried to build like a little credit card tapping machine on my 3D printer so that when it goes, please present your card, it kind of goes tap and then does all that kind of cool stuff. But yeah, it's, again, more complexity for not much gain. Less is more, somebody said today.
Yeah, but where is the fun?
Well, this is the thing. Where is the fun? That's right. Better make sure I take this home, otherwise I'll be in trouble.
Hey Andrew, this is Sharad here. I'm actually also struggling with my app initialization time. So as you mentioned, like a content provider runs in a parallel of application, but what I debugged, the application was running before the content provider and I was not able to do anything in parallel. Would you like to suggest me like how can I do them in parallel?
That's bizarre. So yeah, the startup sequence for an Android app should be content providers first, and there'll be one instance of each content provider, I believe. Then you have your application class, and there can be more than one of those, which is the crazy part of an Android application. If you've got multiple processes, each one gets its own Android application class, and then it should launch services and activities. So in theory, your content provider should run first. And if you've got multiple content providers, there's like a init order flag that you can set, and it works really well. So rather than 1, 2, 3, 4, 5, the highest number gets executed first. So you have to kind of go 5, 4, 3, 2, 1, if that makes sense. So the one with the biggest number gets done first. So yeah, so there should be a couple of ways that you can force your content provider to be ran, but I would have expected it to have been done first, which is what the reason why Firebase uses content providers to initialize the Crashlytics library is because it wants that to be the very first thing that gets run by your app, so that if there are any crashes in the application class or starting up any of the other bits and pieces, Firebase will capture those and still do the logging to the back end. So, yeah.
I actually never thought of having multiple content provider. So you think like if I want to do something in parallel, I can have multiple content providers?
Yeah, you can have as many content providers as you like, yeah. Yeah.
Nice.
Yeah.
And like, as you said, you are using a terminal. When you take off your terminal from the dock, it calls a configuration changes, right?
Correct.
And so in that case, I mean, is it must to use that UI mode as a config changes in the manifest?
Yeah, well, if you don't...
I'm just trying to understand this.
Yeah, if you don't have the on configuration change UI mode in your manifest, it will trigger a restart of your app. And then the idea is that when you take the terminal out of the dock, in theory it could load different sets of resources. So it does the configuration change of the app to then sit there and say, okay, as with Kartik's talk earlier about the language packs, and it goes, okay, you get your French language pack or your Spanish one. You also have one for desktop and not desktop mode. So you can then pull out different resources. So if you had an icon to say, you know, where is your dock, where's your terminal sitting, you could have a picture that's, you know, in the dock or in the air, and it would pull it from a different resource folder as well. So that configuration change lets you pull different resources. We don't change the app when it's out of the dock. So for us, we just go, I don't want to restart the app. I just want it to kind of keep on running. So I just ignore that one. And we don't actually do anything internally when it does. We log the fact that the change happened so that we know that people keep doing this all day. But we don't actually do anything with that information.
So thank you very much.
No.
Yeah. Hi Andrew, this is Sahil. I have a couple of questions. First one is regarding that testing which you are doing for the manifest.
Yep.
Is it the JUnit test or are you doing the Android?
It's an Android test because it runs, it needs to build your app to then do the manifest merging so that it gets all the manifests from all the libraries, and then it runs it on a sort of an Android emulator.
And the next one is, like as you mentioned, that you are using Jetpack Compose. But the interesting choice of library, you are using Coin in place of Dagger or hilt?
Yep.
Like any particular reason for that one?
I've yet to meet, well, my choice of coin predates Jetpack Compose. So I was using it, I don't use it because of Jetpack Compose, I was using it before. And I was using it before because I never managed to get Dagger working once in about 25 different applications. I cut and paste the setup from the previous app where it was working into my new app to get it working in that app. And yeah, I just struggled with Dagger. I never used Hilt. I'd already switched to Coin when they came out with Hilt, which was to save us from Dagger's horribleness. And I never had the energy to go and look at the other one. The other one that some people use, I think it's called Anvil, which is from Square, which is supposed to be quite good as well.
Okay, thank you.
There's one thing, like if you are thinking Dagger is horrible, then I'll say Hilt is very good. I'm every day using it. It is like zero problem. It's like very, very refined version of the Dagger.
Yeah, I'm almost at the point where I don't think I actually need one, as long as I can just, yeah. Yeah.
Sure.
It seems like a lot of effort for not an awful lot of gain these days.
Hey, hi Andrew. I have one question. So the device which you are using, so it should run Android OS in order to use your application, right?
Correct, yes.
So let's say there is I just want to understand, like, is there any other OS provider which is already doing this? Let's say other than Android OS, is there any OS exist?
Yeah, so I mean, the project that I work on is called Next Gen because these are the next generation of credit card payment terminals. If you're out there today at the shops, you'll see all the old ones will be the ones with a tiny screen. They almost look like a Nokia phone. You know, they've got the physical keypad on the bottom. They've got the small screen on the top. They look clunky. They're really old. These ones are all running Android. This one's from a company called Verifone. There's lots of other companies out there that make similar terminals. Ingenico, Pax, Clover. Who else? There's probably about 3 or 4 other ones. And they all run different versions of Android. It's kind of a secure version of Android, so they take the base version and strip out the bits that are insecure, lock down, add in their own software. So I can't deliver my apps to this using the Google Play services, or sorry, the Google Play Store, because the Google Play Store isn't on here. Mm-hmm. But the hardware manufacturer has their own version. So when I want to deploy my app to a production terminal, I have to upload it to some awful, I hope there's nobody from Verifone here this evening, awful website, portal, and then it gets pushed in a similar style to the Google Play Store onto one of these services. So yeah, there are limitations to these things. They run old versions of Android software, but these are next gen.
Oh, cool.
If we ever get to Android 14, it'll be, I don't know what you call it after that, next gen.
Agreed. So why I'm asking this question is I'm just thinking out loud. So there may be a version of Linux also, let's say, if it is deployed, if it is possible in the world of containerization, so you can deploy your application into a container which actually runs the Android application in it, and you can deploy it anywhere.
Yeah, that would seem plausible. It would just be whether it would be secure. But yes, I mean, so the other devices from Verifone run versions of Linux, so you can write applications like my application where you tap on the thing in C++, all that kind of thing. Would you ever get Flutter on there? I don't know. Would you want to containerize it? I mean, these things aren't particularly powerful. I mean, they look bulky, but they are designed to be cheap. So, there are going to be thousands of these things out in the wild. They're not a premium device because a merchant doesn't want to spend $1,500 on a terminal. They want to spend $300 on a terminal and just take coffee orders all day long. So it's not got the best screen. It's not got the most memory. It's not got the most powerful CPU. So things like containerization is just going to make it slower than it already might be. But yeah, it's possible. But yeah,
because there are already Linux versions which are as small as Alpine. So it is very small Linux. So it can make miracles.
Yes.
You see Raspberry Pi.
Yeah.
It is so small, but you can really run containers in it, and you can use as a small server to communicate it. Because I'm thinking, like, if you have such kind of thing, then your application can be deployed anywhere.
Yes, I mean, to answer that question, Android is also kind of designed to run anywhere, right? So anything that runs Android, I mean, so my app, not only does it run on here, but we have a sort of a fake version for manager types to take to demos that runs on a mobile phone. It's the same version. We just have a fake, credit card button that says, "Oh, pretend there was a credit card tapped. And then so people can go and do a demo on a mobile phone. In theory, you could run it on an Android TV. It would look awful, but if you wanted to, it would work on an Android TV. It probably wouldn't work on an Android Wear watch, but yeah.
Yeah, agreed. Thank you.
Right. Any other questions?
All good? Oh, prizes? No, not prizes.
He almost covered my question. Any particular reason to choose Android 8? Or is it provided by the vendor?
Yeah, I would love to be on something that's not Android 8, but yeah, it's provided by the hardware manufacturer. So this terminal has been around. I want to say this is one of the first next-gen terminals, so this is probably 3 or 4 years old now. It's on Android 8. Newer credit card terminal devices are probably on 10. You can probably get some that might be on 12, I don't know. But yeah, the 8 is just because history. There's no reason. It may be, as with anything, because they're taking the Android open source software and then customizing it, there's always going to be a lag between, oh, there's a new version of Android, and then them stripping out and then making it secure. So yeah, there's always going to be a delay. But this one's on 8. Like I say, I've got one that's sitting on my desk that runs Android 7, and I think Mitch was saying that there's another one that's got Android 10. So.